Welcome back to this example of a simple but complete simulation. In the first part, part A, we introduced the problem, technology, and we also dealt with the Poisson random variables, which will be dealt with a little differently than the uncertainty associated with our cost of scooters, which is the normal distribution, and the selling price of scooters, which is the continuous uniform distribution. So we've essentially taken care of building our brain. So we have our parameters here. Why do we have parameters here? Well, in case we want to do sensitivity analysis and change things, we've got one place where we can go to make those changes. So we built our Poisson random variables. You saw those here. We're going to use them in our calculation. So let's see what the calculation is going to look like. This is step 1B now. We're going to start with our calculations. The first thing that happens with our problem is we have an arrival of monthly scooters to repair. And you can see in this example, I currently have 8. And this is the number that comes from this page. 8 has been selected, and the value is placed here. So that tells us that we're going to have 8 scooters to fix, and each one of those scooters is going to have a unique cost and a unique sales price. So how do I do that? Well, I do that by building this table. This column of numbers here in column I is just a set of index values. And I generally have as many values of this index value as 3 times the value of lambda. That would be 21. In this particular case, I have 30 just to be sure and careful. I might be able to change this to an arrival of 8 or 9. So I want some latitude to be able to change that, but 3 times this number is what you want for this index row. Why do we need this index row and all of the attendant random variables that we've got here? Well, we're going to generate an unknown number of costs, 30 costs, and we're going to say, well, I don't need all of those costs. I only need 8. So I'm only going to calculate the values for the first 8 elements in this row. This is the a function that uses that refers to this column. This column is the norm inverse function that's using these parameters to generate a cost. And here I use an if function and says, look, if the value of the index row is less than or equal to 8, count it. Otherwise, make it 0. That's what's being shown in this particular formula. So when we finally get to 9, it becomes 0. That way I can accumulate just the number that I need, 8, and I'll sum it down here, and here's the value that's summed for this column. Why? Because all these that are here and blacked out are 0 values, okay? You can see if I hit F9, recalculate the workbook, it's now 10, it's gone down to 10. The same thing is happening over here on the right-hand side where I'm calculating the selling price. I calculate many selling prices, but I only count 10 of them. Here's the 10th one. And I do that by doing the same thing, an if statement that says if the value of the index value over here is less than or equal to 10, count it. Count this value here in the adjacent row. Otherwise, make it 0. And of course, I've got conditional formatting that makes this 0. So now we have a sum for the cost, a sum for the sales, and then I can calculate the all-important, what I call the golden cell, because it's what we're after. It's the gold we're looking for. And it says, why don't you take N42 and subtract K42. In other words, subtract the cost from the selling price to get the marginal return on the value. So this represents a single iteration or a single experiment in this simulation. Now, what do I need to do? I need to take this particular value and I need to make it the northwest corner of a data table. And the data table is shown here that has, I think, approximately 500 values calculated in it. I simply created a data table. I grab the area like this, there would be no numbers in here. I go all the way down to this point. I go to data. I go to what if. I go to data table, and then I give it dummy values for the row and input. Any two empty cells will work. And these are just dummy variables. There's nothing in those cells, but make sure they're empty, and it'll generate a table like this. And you can see that these are now 500 experiments for this golden cell. The last step in the process is to take this information and to summarize it in some particular way. And that summarization is shown here in this area. Here I've got some summary statistics. I've called this data, I identified it as something called SIMDAT. I gave it a name, and makes it easier for me to ask it to calculate the average of SIMDAT, the standard deviation of SIMDAT, the minimum, the maximum, and the median. This gives us valuable information. So you're going to make on average $960 per day, and or per month, excuse me, and the median is a little bit less. And then I create a frequency distribution from this data over here. I select my bins. I look at my min and my max, and I make sure that I include that range between the low and the high value. And I use the frequency function to generate an array here that counts values in each one of these cells. This cell is a cell 0 here. Bin is all values between 2,500 and just a small amount, maybe a penny more, up to 0. There's 118 values there. Then the next thing that we do, obviously, is we create a graph of the same information. And now we've taken this graph of frequencies and placed it on this graph, this table versus a graph. I've also added the frequencies here and the cumulative frequencies. Why? Because I'm going to ask some serious questions about what's going on. The cumulative frequency is nothing more than the values of the frequencies here added one to another. I could ask the question, for example, what is the probability of making 0 or a negative number of dollars in a month? And that probability is 37.8. Now it'll change when I hit F9. Now it's 42, 44, 40, 42, 40, 44, 41, 45. So it's probably going to be somewhere in the vicinity of 42 or so. If I had a much larger sample size, that number would stabilize and it wouldn't be changing the way it is now. 500 observations of that golden cell is not enough to give you that much stability. But I can't answer those questions. About 40% of the time, you're going to make no money or lose money. And that's a question that's asked here. And of course, this simply takes does a count. I count all of the values in the data, SIMDATA, that are less than or equal to 0, and I divide that by the total. That's 500 total over here, and it gives me 39%. So there you have it, a complete view of a simple simulation. Of course, we'll be working with more complex simulations later, but now you've been through an entire simulation from start to finish. That concludes this video.